These are the newest images of 3I Atlas from yesterday, and I'm pretty sure this is shocking. This is actually the most shocking anomaly we've seen about this object, because the only explanation was breakup. In this video, I'll break down everything we know about what's actually happening with 3I Atlas. Let's first talk about why everyone was convinced it should be fragmenting or breaking apart, then we'll discuss new images. On November 9th, we captured these images showing a tail and a sunward tail extending millions of kilometers. But for comets, gas flows out at only about 1,500 kilometers per hour, which is pretty slow for space. For the tails to stretch millions of kilometers at that speed, the comet would need to shoot gas constantly for months. But images from just a few days earlier showed absolutely no tail at all, which is just one weird part. The comet would need 1,600 square kilometers of surface area, absorbing sunlight. That's a sphere 23 kilometers across. But Hubble measured 3I Atlas at only 5.6 kilometers across, so the math showed it needed to be 4 times bigger. We calculated how much material these tails must be carrying away from 3I Atlas, and the numbers are pretty shocking. Estimations showed 3I Atlas has to be losing about 50 billion tons of material per month, which is pretty disturbing. This is disturbing considering the object is supposed to weigh only about 33 billion tons, but we've seen this before. The comet Shoemaker-Levy 9 broke apart in 1992 and released way more material than the original comet weighed. That made perfect sense once we realized it had broken into 21 different pieces with more surface area exposed. These pieces then have more surface area for the sun's heat to cause more ice to turn into gas, creating more visible jets. So, the only logical explanation for the 7 jets seen on November 8th was that 3I Atlas had fragmented into pieces, and the massive multi-million kilometer tails in the November 9th images, because there's no way a solid object can lose more mass than it weighs. So, let's talk about what the new images actually reveal on November 11th. Astronomers pointed a telescope at 3I Atlas. When they published their findings, they gave it a very simple title: 3I Atlas still single, not broken into pieces. Not fragmenting, not scattering debris everywhere, but here is what makes these images so important. They actually measured and analyzed everything in detail. The images show 3 Atlas is about 1.5 astronomical units from the Sun. That's about 214 million kilometers. And it's a little over 2 astronomical units from Earth, which is about 320 million kilometers away. They observed a huge region. They observed a region around the comet that was about 500,000 kilometers wide, so they were looking at a huge area. What they found was one single bright nucleus that is the solid center of the comet, surrounded by an active glowing cloud. The coma has a complex shape with different structures in it. They saw 2 tails pointing in opposite directions, just like previous images. One tail is pointing almost directly toward the sun. They measured its angle at about 106 degrees. This is called an anti-tail. The other tail is pointing away from the sun in the normal direction. At about 301 degrees, they used different image processing techniques. They stretched the brightness, made contour maps, used false colors, looked at the image in rings moving outward from the center. Every technique they tried was designed to find even small pieces. If they were there, they specifically wrote, the image region showed no hint of fragmentation. If 3I Atlas had broken into 16 pieces, like the math suggested, those pieces would be spreading out. They would be visible. They would leave trails, but the images showed none of that. So we are not just saying the object looks like it held together. We are saying astronomers carefully examined a massive region around it using multiple analysis methods and found zero evidence of any breakup whatsoever. And remember, this object just went through the most intense part of its journey. It passed closest to the sun on October 29th. It got heated to extreme temperatures. We expected the thermal stress alone to have cracked it apart, the pressure from all that gas shooting out. But 2 weeks later, it is still one solid object actively producing enormous jets in multiple directions. So if the object really is natural, scientists need to explain how this is physically possible. Here are the theories I have. As of right now, we know 3I Atlas is billions of years old. For all those billions of years, the comet was flying through deep space, getting hit by cosmic rays. These are high-energy particles that slam into objects. Think of it like radiation, slowly cooking the surface over billions of years. The James Webb Space Telescope found something interesting that supports this idea. 3I Atlas has way more carbon dioxide compared to water than normal comets, about 8 times more than the usual ratio. This could be because of cosmic rays. These cosmic rays could have also created a weird crusty layer on the surface. This crust might make the ice underneath it sublimate in really strange ways. Maybe it creates channels or pockets that give the comet way more effective surface area than we can see from the outside. Another theory is, maybe we are calculating incorrectly. Maybe sublimation can happen faster than we think, under certain conditions. Maybe the jets are not carrying as much mass as the calculations suggest, the 50 billion tons per month number. The problem with this theory is scientists have been calculating comet mass loss this way for decades. The method works. So if it is suddenly wrong for 3 Atlas, we need to understand why. Maybe the tails are just really good at scattering sunlight. Maybe they look bigger than they actually are, in terms of mass. The calculations came from looking at brightness. If the real mass loss is only 5 billion tons per month instead of 50 billion, the numbers would work much better. That is still extreme, but at least possible. The problem with this theory is scientists have been calculating comet mass loss this way for decades. The method works for other comets, so why not this one? If it is suddenly wrong for 3 Atlas, we need to understand why this object is different. What makes it special? What are we missing in our understanding? This comet has traveled from another star system. It spent billions of years in interstellar space exposed to conditions we can barely imagine, cosmic radiation, at levels we have never studied. The surface chemistry could be completely different from solar system comets. The structure could be fundamentally altered in ways we have never seen before. This makes it incredibly unique. Scientists are now racing to gather more data before it moves too far away. Every observation could reveal new clues about its mysterious behavior and composition. Telescopes worldwide are tracking it. The James Webb Space Telescope continues to monitor its chemical composition, while ground-based observatories track its trajectory and activity patterns, looking for any changes in behavior over time. What we learn from 3I Atlas could revolutionize our understanding of interstellar objects and how they form in other star systems. It is giving us a glimpse into alien solar systems. This is why 3I Atlas is so important. It is not just another comet, it is a messenger from another star, carrying secrets about planetary formation across the galaxy. The fact that it survived perihelion passage without fragmenting, despite all the stress, tells us its internal structure must be remarkably strong or fundamentally different from what we expected. Every piece of data we collect brings us closer to solving this puzzle, but also raises new questions. This is how science works. One mystery leads to another discovery. The mystery of 3I Atlas reminds us how much we still have to learn about the universe. Even in our own cosmic neighborhood, objects can surprise us and challenge everything we thought we knew. So, keep watching this space literally as 3I Atlas continues its journey through our solar system, and scientists continue unraveling its secrets. There is much more to discover. Thanks for watching. If you enjoyed this deep dive into the mystery of 3I Atlas, hit that like button and subscribe for more fascinating space discoveries and cosmic mysteries.